Okay, so this is 11, chapter 11, 11.4/11.7, corresponding parts of similar triangles and proportional segments. Okay, so let's go straight to our first investigation. So it says, given these two similar triangles, and so obviously you can see that it's 1 to 2. So if it's 1 to 2, that means all the sides are going to be 1 to 2. But what about parts of the triangle? For instance, let's do the altitude. So it says construct altitudes AD and RU. Okay, so you can recall how to construct an altitude, and it says AD, so we're going to go from A. And remember, you make a little smiley face. And you can arc out here. Based on this point right here. Make another arc over here, and then we'll get our ruler and connect that. And then do the same thing over here. Let's make it a little bit smaller. So make a smiley face. Place it on this point. Make an arc out here. And another point. And make another arc. And then let's use our ruler to make the altitude. So connect R through there. And then let's connect A through that one. Okay, so if all the sides are 1 to 2, does that mean the altitudes are going to be 1 to 2? And so you can easily check with your compass. Let's go get the measure of this altitude. Okay, so you get that exact size. And then if it is 1 to 2, then it should be about 2 of these. Okay? And so mine are a little off. And of course mine is digital. Yours is probably a little bit better. Yeah, so see, mine's a little off. Okay, but it should be 1 to 2. Let's try constructing an angle bisector. We'll just do one more. So the angle bisector, it needs to come from C and from T. So let's do one last construction. Let's do the angle bisector. Maybe a different color. So we're going to bisect this angle. Maybe mark over here. And then let's go bisect this angle over here. Let's use our ruler and make that angle bisect. Okay, so there's one. And there's this one. So again, with these angle bisectors, need a 1 to 2 ratio as well. So let's check to see how big those are. So that's about that size right there. And so if it's 1 to 2, let's see, it should technically go about twice. So 1, yeah, and this one came out a little bit better, 2. Okay, so I just copied that one. There's 2 of those. Okay. Yeah, that one came out good. I don't know why the altitude didn't come out very good. It kind of looks like this one's not very perpendicular. Okay. So, but the point is, this altitude right here, this purple one, should be half the size of that one, because this 4 is half the size of this 8. okay, and these are similar. Okay, this angle bisector, CF is half the size of TW, okay? So the ratio is 4 to 8, which equals 1 to 2, okay? The angle bisector, CF, also is 1 to 2, which is to TW, okay? So anytime you deal with similar triangles, every part will have that same proportion. So here's how the conjecture goes. If two triangles are similar, then the lengths of the corresponding angle bisectors, the altitudes, and the medians, okay, we didn't do the medians, but if you were to construct the medians, those are going to have the same proportional ratio. In this case, it was 1 to 2, but it can be whatever. Okay, so they're going to have the same proportion to the corresponding side lengths. So again, the side lengths were 4 to 8, which was 1 to 2. Okay, and this is the first conjecture that you're going to have memorized. So put a star or whatever it takes next to that conjecture. Okay, let's go to the next investigation. On this one, it says to construct an angle bisector. Okay, so let's get our compass and let's make an angle bisector at L, let's say. Okay, so make an arc. Place your compass here. Make an arc in the interior. Swing it around, place it on this one. Make an arc there. And use our ruler to make our angle bisector. All right, here we go. Okay, so what I want you to focus on is these two segments, or 4 segments. Let me get my highlighter. I want you to compare this one to this one, okay? So if you compare those two, okay, that ratio is 3.2 to 6.4, which reduces to 1 to 2, okay? Question is this piece right here related to this piece over here? Okay, so let's check with our compass. So this is 1 to 2. Does that mean this segment 1 to 2 to that one as well? So let's measure this yellow segment over here. Let's measure this one. So let's look at that measure. It's about that big. Okay. That's good. Okay. Now, let's see if this pink one is twice that yellow one. Okay. Of course, mine's digital, so mine's going to be a little off. Yeah, of course it would be. Okay. All right, so it's a little off on mine. Again, mine is digital, and that goes back to constructing. Okay, your paper should be a nice, perfect construction on your actual paper. Okay, digital doesn't work so well. However, this is the case. Okay, so if this is X, this is going to be 2X because it's going to go along with this proportion here. Okay, or ratio, I should say. So if 3.2 is to 6.4, which is 1 to 2, well, then that yellow one is going to be half of that pink one. Okay, so it does divide that opposite side proportionally. So it says a bisector of an angle in a triangle divides the opposite side into 2 segments whose lengths are the same ratio as the 2 lengths of the 2 segments that form the bisected angle. Okay, so just to kind of make it a little simpler, okay, let's draw a little separate picture right here. If I have a triangle here and I have an angle bisector, I can call this A, this B, this C, and this D. Okay, this proportion is always going to be true if you have an angle bisector. You could say A is to B as C is to D. Okay, we can also write it a different way. You could say A is to C as B is to D. Okay, and there's proportions that you can always write these a little bit different. Okay, All right, one more investigation. Last one, the one with the parallel lines. So it says, given the following set of parallel lines, measure the segments A, B, C, and D, and then let's compare them in ratio form. A to B, C to D. So if I get my ruler and I measure this, this looks like it is 1.5. And this one up here looks like it is like a little bit of 6. So 1, 2, 3, 4.5. Okay. Let's go ahead and measure this one over here. Okay. Well, let's before we do that, let's just compare this ratio. So 1.5 to 4.5. Okay, 1.5 to 4.5. What is that reduced to? 1.5 goes into 4.5 3 times, right? So this is like a 1 to 3 ratio. So this is 1 to 3 reduced, okay, a ratio. Does that mean this is 1 to 3 as well? Okay, let's check with our compass, okay? And again, mine's digital, so let's see if this actually works out. So I'm going to go measure how big this part is. Okay. Looks about right there. And so let's check to see if this is 1. And how many should I make? Actually, I want to make what? 3 of them? 1, 2, yeah, pretty close to it. Okay. So that side also comes out as 1 to 3. Okay, and so whatever those measures are, it's going to come out as a ratio as 1 to 3. So A is to B is equal to C is to D. Okay, and in this case, we had proof here. Hopefully it worked out. And it was 1 to 3. So here's your last conjecture for this unit. If a line is parallel to one side of a triangle, and it intersects the other two sides, then it divides the two sides proportionally. Okay, so the two sides are going to be proportional, just like I wrote down this right here. So I would box this part right here. A is to B, and C is to D. Only if you have, again, parallel lines. All right, that's our third conjecture. Okay. All right, 2 more actually. We won't investigate, but the converse of that also holds true. So if you see a line and it divides the triangle proportionally, for instance, in this example right here. So here we have 2 is to 5, right here to here, as 4 is to 10. Do those equal? Yes, they do, because 4 over 10 reduces to 2 over 5. So if that is true and they are proportional, then it's got to be parallel to that third side. So they won't mark it for you. You got to know this from now on. So if you see 2 corresponds to 5 and 4 corresponds to 10 the exact same way, then that forces these 2 to be parallel. A little bit more on parallel lines. Okay, they don't necessarily have to be in a triangle. Let's just say you have 3 or more parallel lines. Okay, so for instance, in this picture, this one, and this one are parallel. It doesn't make a triangle, okay, but it makes another shape. And so it has 2 or more transversals, okay, you can have 2 or more. Then they divide the transversals proportionally, okay. So this part right here, this part is a 3. That 3 corresponds to this 5. And it should correspond the same way over here. That 4.5 should correspond to this part down here. Okay, so the way this ratio would work out, 3 is to 5 as 4.5 is to 7.5. Okay, and so if you reduce that, that is 3/5. All right, let's try some examples now. All right, so we got an angle bisector. So here's the part that you have to remember. 18 is to 12. plus 5 is to x. Okay, and so you just have to cross multiply. 18 times x is 18x. That equals 12 times x plus 5. Okay, you can skip this line if you remember to do the distributive property. This would be 12x plus 60 equals 18x minus the 12x minus 12x. 6x is equal to 60, which x is going to equal 10. Okay, and so remember that property. This segment is to this segment as this segment is to that segment. Okay, we have some parallel lines. So let's think back to that conjecture that we just finished doing. This part is proportional to this one as this part is proportional to that one. Okay, so let's write it out in the proportion. X plus 6 is to x as, what's that blue segment up here, guys? 21, right? 21 and 9 make 30. As 21 is to 9. Okay, so let's cross multiply. 21x equals 9 times x plus 6. 21x equals 9x plus 54. Minus 9x minus 9x. That leaves me with 14. No. Can't add right now. 21 minus 9 is 54. Okay, 54 divided by 12 is, I don't know my calculator, looks like it would be 4 and a half, 4.5. So x equals 4.5. Alrighty, let's go to the next one. Some more parallel lines, okay, kind of the same property. Okay, now the y is a little bit different, so I'm going to save that for a second, but let's do this one. 4 is to 6 as 2 is to x, okay? And notice it's not drawn to scale. Don't ever get confused just because it's not drawn to scale. Just stick to the property, okay? So we're going to say 4 is to 2 as 6 is to x. Okay, it should be pretty easy. That's 12 equals 4x divided by 4, x equals 3. Okay. Now the y is a little bit tricky. Here's where students make a mistake. They'll write it like this, and I'm telling you, this one is wrong. Okay. I hate to write the wrong stuff down, but I don't want you to do this. Some people will say 4 is to 8 as 2 is to y. Okay, so they're looking at this. They're saying 4 is to 8 as 2 is to y. Okay, that one will not work. Okay, so this is wrong. You need to think of it as two separate triangles. So watch here when I draw the little one and then when I draw the big one. So the little one is 4, 8, and 6. The big one is 6. And over here, it's 6 plus x. Okay? And then over here is my y. So here's what you want to use. You want to use 4 is to 6. Earlier, we did it to 8. Okay? As, you could say 8 is to y. Okay? So it's the 6 that we need to work with, not the 2. So 4 is to 6 as 8 is to y. Let's cross multiply. That's a 48. For y, y equals 12. Okay, so on some of these, I would draw these two triangles separately. Okay, whenever you see a triangle within another triangle. All right, next example, it says identify the similar triangles, explain why they are similar. Okay, so a little preview. And it does say MN is parallel to AB, so MN is parallel to AB. So if they're parallel, then we have some congruent angles because they're corresponding. This angle is congruent to this one. That one is congruent to this one. So we can say the two triangles are similar by the angle-angle conjecture. Okay? So right there. Triangle CNN would be similar, not congruent, sorry, to triangle CBA by the angle-angle. Okay? Now let's solve for AB. So here's where I would like for you to draw the triangles separately, because it'll make it a little bit easier. Okay, so here's one triangle, the small one, and then here's the large one. So the small triangle is 6, 4, and 8. The large triangle is 14, and then that's all we know. Okay, so let's work our way over there. At least we have one ratio to work with. So I could say 6 is to 14 as 4 is to CB. Okay, so I can solve for CB right there. So let's cross multiply and get my calculator. Four times 14 is 56. 56 is equal to 6 CB. Divide by 6, divide by 6. So CB equals 9.33. CB equals 9.33. So CB, I should probably label my triangles over here. This is CB, this is A, this one is C, this is M, and N. All right, so this is 9.33, okay? Well, if that's 9.33, we know CN is 4, so we can just subtract 4 from that, and that'll get us NB, which is 5.33. Okay, and then to get AB, that's the bottom side. Let's write out another proportion. We can still use 6 is to 14. 6 is to 14 as 8 is to AB, and that's what we need. So cross multiply, 8 times 14 is 112 equals 6 AB, divide by 6, divide by 6. This one's going to be 18.667. 18 and 2/3. So 18 and 2/3, 9 and 1/3, and 5 and 1/3. Okay, so again, notice these proportions, how I write those out first. And you always want to make sure that they all relate, okay? All right, last one for the day. So we got some parallel lines again. Okay, doesn't necessarily have to be in a triangle, but if you have parallel lines, you got to know this conjecture. This is to this as this is to this. Okay, so let's just set up a proportion and go from there. 5x is to 8x as 3x is to 60. Okay, and you can write it a different way too and still be correct. All right, one thing that I would like for you to do is notice if there's an x on top and an x on bottom, they can simplify. Same thing over here. If there's a 3 and a 60 on top, those two can simplify. That simplifies to a 1 and that simplifies to a 20 because 3 goes into those. So now you're looking at a simpler ratio to work with. 5 is to 8 as x is to 20. Okay, cross multiply, 5 times 20 is 100 equals 8x. That's going to be a decimal. X equals 12.5. And that was our last example. Be sure to go over these 3 main conjectures.